All right, we are now at one of the most important theorems in calculus. So we are going to talk about the intermediate value theorem, which is why we make such a big stinking deal about continuous functions. So the only condition that you need to use the intermediate value theorem is your function must be continuous on a closed interval. What that means is if you wanted to look at 1 over x, you can't include 0 because we don't have a continuous function at 0. So you could look at 1 over x from like 1 to 5 or 1 to 10 or -10 to -1 because the function is continuous on those domains that you're choosing, but you can't just choose the entire domain. So the function must be continuous on an interval for that entire piece, including the endpoints. Okay, I'm going to go ahead and erase that. Okay. Sorry, go back and forth a little bit there. Okay. So with that being said, let's look at the full theorem. If z is any number between these two function values, so again, I'm going to kind of draw this graphically and we'll just stay here in the first quadrant. So I have an A, I have a B, I have an f of A, and I have an f of B. And I have some continuous function. Oh, that's not a function. All right, I have some continuous function, let's say, that does this. Okay, and I'm purposely having like a little bit of a squiggly outside of my bounds. What the intermediate value theorem says that for any number between f of A and f of B, I know that I have to have some number along my x-axis such that f of c equals z. So between here and here, I have to have numbers between f of A and f of B, like that makes sense. And so really my c is in this interval, that's fine. But it's just guaranteed that between these two y values is some number and it has to correspond to the two x values here. Now it is not guaranteed to have any numbers outside of that domain. So or that range, excuse me. So you might have ups and downs. Those are not guaranteed to be hit. Only numbers between those two y values are guaranteed by this theorem. And it's really helpful for zeros. So show that this has at least one zero on this interval. Well, we don't include the endpoints, okay, so that's important. But we're gonna look at, okay, well, what is f of 0? It's 0 minus the cosine of 0. The cosine of 0 is 1. So I have -1. That's a negative number. F of pi over 2 is pi over 2 minus the cosine of pi over 2. Cosine of pi over 2 is 0, and so I'm just left with pi over 2, which is a positive number. Now the big piece here is this function is a linear combination, so a plus minus multiplier of two continuous functions. So f of x is continuous. Give me a little bit of some writing room down here. So since f of x is continuous on this interval, and f of 0 is negative, f of pi over 2 is positive, Well, if I go from negatives to positives, and I have a continuous function, then I have to go through the x-axis. Like I have to have a 0. F of x equals 0 at least once. Now, it could be more than once. I don't know. Like, again, in the squigglies, I could have had something like this, right, where these values are hit more than once. I'm not guaranteed more than once, but I am guaranteed once. So this is going to be really helpful when we need to find zeros on certain domains, but it might not be nice and pretty. Like to find this 0 might not be great, or be able to do that without a graphing calculator. And so we need to be able to know, like, oh, if I plug in 0 and I plug in pi over 2, I have a negative and then a positive output. So I have to cross my x-axis at some point between 0 and 2. 0 and pi over 2, excuse me.